Yeah, my name's Gabriel Geiger. I'm an investigative reporter at Lighthouse Reports, and I was the lead reporter on this suspicion machines investigation where we took a look at the use of algorithms in European welfare systems. I need to talk a little bit about Lighthouse Reports or I'll be fired. So we're an investigative newsroom, nonprofit, offices in Utrecht and Athens, and typically what Lighthouse does is we build a consortium of media partners and publish at the same time and try to sort of tackle complex transnational investigations. Lighthouse isn't a platform, so we don't publish on our own website. We're always publishing through media partners. And a typical Lighthouse investigation tries to combine more traditional reporting with some sort of specialist skill, so data science in this case, or maybe expertise with different freedom of information laws or money trails. And in the case of this investigation, we worked with Wired and Vers Beton, which is like a local Rotterdam metro paper. When we started this investigation, we did so with the conviction that algorithms are increasingly making life-changing decisions about people, and that one of the most sort of pernicious examples of this was in welfare systems, where algorithms were making decisions about benefits that people need to live. And some of that reporting has already come out in the Netherlands and Denmark and Spain. Some of it will come out in the fall. And we kind of tried to tackle this across 4 different themes. So we wanted to do one full-scale audit of one of these algorithms. So have the code and everything and be able to poke it and prod it and test for discrimination. We wanted to tell the stories of people who are actually affected by these systems. We wanted to kind of unpack the politics that were driving the adoption of them. And we wanted to outline the market of private vendors and consultancies that were developing and pitching these systems to governments. And sort of the crescendo, I guess, if you will, of this investigation was a 4-part series that we published in Wired in March. And the centerpiece of that series was a full-scale audit of an algorithm used in the Dutch city of Rotterdam. And every year for the past maybe 15 to 20 years, Rotterdam has put thousands of its welfare recipients under investigation for fraud. And it's important to understand that these investigations can be life-changing. So fraud investigators are empowered to turn over people's lives. We have testimonies of from one mother example whose house was raided at 4 a.m. by fraud investigators. They were searching through her laundry, counting her toothbrushes, asking her personal questions about her sex life in front of her children. And it's an investigation where the smallest mistake, forgetting to report 10 euros you receive for pizza, can involve months of your benefits being reclaimed by the government. But in 2017, something changed about the way that the city started selecting people for these investigations. So what it did was it used an algorithm that looked at 315 data points for each person and assigned them a risk score between 0 and 1. And the people with the highest scores were automatically flagged for one of these investigations. So for this project, also one thing, please feel free to interrupt with any questions you have or while I'm talking. I've budgeted some time at the end as well, but for this investigation, we had full access to this algorithm. So what that means is we had the code to run it, we had this machine learning model file that produces these risk scores. We had all the data it was trained on, so in this case, past investigations. And then we had all the technical documentation from the city's data scientists. So we had some understanding of why they made certain choices. And what we did with all that information was to design an experiment to test for bias. So which groups are disparately impacted by this system. So you can see some of the sort of top line results of that experiment in the graphic on the right. So, you know, young people, parents, women, people who don't speak Dutch all receive much higher scores than a sort of counter characteristic. And just to sort of briefly take you through how we presented the results of the experiment, which will also help to explain how we actually did this, and how we approached getting the information needed to do this. So in the story, we kind of use two archetypes, so two sort of made-up characters that try to illustrate how this algorithm works and what the effects are. So these archetypes are Sarah, who's a single mother, and Yusuf, who's a recent immigrant to the Netherlands. And what we try to explain here is how these 315 data points per person look in the algorithm. And these different data points or variables range from demographic characteristics like gender or age to your language, ability to speak the Dutch language, your relationships, how many partners have you had, are you married, to things like to the notes that caseworkers are writing about you. So caseworkers commenting, she wasn't wearing makeup today, she doesn't look suitable for a job. That's converted into a variable that's then fed into the algorithm. So in the case of Sarah, we try to show how a struggling single mother's life is sort of flattened by the system. So you can see on the side the sort of narrative description, and here how that's translated into variables that are then used as inputs for the algorithm. So you can see here, like comments from the caseworker are then converted into this comment on appearance field. And it's we try to show the same thing with Yusuf. So he immigrated from Iraq. The fact that he lives in a primarily migrant neighborhood in Rotterdam is also logged here through the neighborhood variable. The fact that he lives with roommates and in crowded housing, the time that the caseworker will thinks he needs to find a job. And then what we try to show is how these different variables actually affect someone's score. So we start with the sort of lowest risk profile, which would be a single white Dutch guy, age of around 50. And then we show one by one, like how these different changes then increase his score. So when you change the gender to woman, the score goes up. Make that woman a mother, score goes up. Make that a single mother, score goes up again. If they were struggling financially, the score goes up again. If they've passed this high risk threshold, that would land them like flagged for an investigation. And then we try to do the same thing with Yusuf. So we start with this sort of archetypical Dutch guy, and then when we change all these variables, his score goes up. And then the sort of other thing we try to explore is actually how this algorithm works. So this algorithm on the inside essentially looks like a bunch of sort of randomish, because it's machine learning, decision trees that people go down through. So it's 500 of these, and they're much larger and much more levels. So we have kind of a simplified version. And what we're trying to show is how sort of baked into using this certain type of machine learning model, different people are judged based on different characteristics. So what that means in practice is, you can see here, if you're a woman, you're asked about whether you have children, how many addresses you've lived at, and whether how long you've been dating your partner. If you're a man, you're asked about whether you speak Dutch and whether you're struggling financially. And then the sort of last thing we try to show is like, okay, we've been following these two individuals, but what about people who look like them on the whole, on the aggregate? And you can see here's a distribution, for example, of people who don't speak Dutch, and you can see in the high-risk category, nearly everyone doesn't speak Dutch, and in the low-risk category, nearly everyone only speaks Dutch. And that's even more extreme when you look at parents. So in the lowest risk category, there is nobody who has children, and in the high-risk category, nearly everyone has children. So that's what we were able to do, but kind of how did we get here? And to understand, I think you need to rewind a little bit to now nearly 10 years ago, ProPublica's machine bias. And this was an investigation, sort of landmark in the space, that looked at software that was meant to predict who was most likely to reoffend after committing a crime. And ProPublica analyzed this system and found that it disproportionately made errors on people of color versus white people. Yeah, it was sort of this landmark in the space, but they were using only the outputs of the algorithm. So they didn't know how the system had actually arrived at its prediction. They just had like this sort of data set of predictions and then whether that person went on to commit a crime. So sort of since machine bias, one of the things that journalists in the algorithmic accountability space have been trying to do is like, okay, can we get access to the system itself so we can test it ourselves and understand how it actually arrives at its predictions? And sort of the background to this as well is that these risk assessment systems have becoming increasingly common. And the sort of pitch for these systems that they're more objective, more fair, more efficient than analog methods. But journalists or any sort of public watchdog are never actually given the ability to test these claims. So you can see here, this purple PowerPoint is from Accenture, who originally built, which is the massive consultancy, which originally built the system for Rotterdam. And you can see in their white paper, they're promising big, bold lettering, advanced analytics, machine learning, no bias. And then this quote below is from an interview with the mayor of Rotterdam, where he said there's no question of bias in inputs or outputs of the algorithm. So we wanted to test that. And when we tried to think about how we would test that, we wanted to think about this sort of life cycle of one of these algorithms. What the goal of that to do is to try to understand what discrimination looks like inside the black box. And this framework is something that applies to algorithms not just in welfare, but in predictive policing, criminal justice. And to investigate this life cycle, like at least for us, we kind of broke it down into these 5 different parts. So the input features, so these are the input variables that you saw. So for example, like gender or number of children or Dutch language fluency. The training data set. So for a machine learning algorithm, what's the data set that it learned to make predictions from? And in the case of Rotterdam, this was past investigations. And the sort of idea here is that if you're feeding a machine learning algorithm, biased or flawed training data, it will just reproduce those same flaws. Garbage in, garbage out. Personally, I think looking at training data is one of the really most underexplored things in this space. So yeah, if any of you are thinking of taking on this reporting, I would really recommend maybe thinking a little bit more about how you could investigate training data. There's model type. So that's when I was talking about like how this machine learning model uses these decision trees. Not all of these different algorithms are a bunch of decision trees. So different model types, I think, come with different fairness implications. Performance. So does the system actually work? In the case of Rotterdam, it was slightly better than random. It was about a 10% improvement off of random selection, so it didn't work very well. And then the last one, and probably the one that most people are like interested in, is fairness. All right, so can you show some sort of disparate impact against a vulnerable group? So with this life cycle in mind, and I don't want to like cheat, like this is something that we very much came up with on the way. So I wish we'd had this graph when we first started, but we didn't. We sort of built it through trial and error. So we devised a FOIA, a Freedom of Information Act request, and sent it across Europe. This is what it looked like. And if you want to, I put a QR code in case you want to actually use this yourself. There'll be a document there that I've annotated a little bit as well, with some different notes of how you may structure your request differently depending on what you know about the system. So basically what it looks like is you're asking for this machine learning model file. I'm going to talk about a little bit about that in a second. This code that's used to train it. You want to know all the input features. You want to know, and this is really important because I didn't do this the first time and really lost a lot of time, is like these data dictionaries. So essentially like a document that explains what each of these variables mean and the database that they come from. And why that's super important is because like the Rotterdam variables, if you look at the names of them, like some of them you can understand, but some of them look like complete gibberish, like PLA, action plan, outsource. And it's like, okay, what does that really mean? Like, so we didn't get this, we didn't ask for this code book originally, and then we got the variables, and we're like, well, we don't know what these mean, and then we had to refoia, and that just cost us a bunch of time. Then, of course, like any documentation like related to it, so this is for like their internal team, like how do you use this thing? Also important, you know, any sort of documents that tell the end users, so in this case like fraud investigators, how they should interpret this score. That's really important as well, is because usually it's quite rare now, I think, for at least these risk assessment systems that there isn't some sort of human in the loop. But there's this sort of outstanding question of how much is the human in the loop affected by an algorithmic risk assessment. You know, do they see, oh, high fraud risk, and they're just, all right, high fraud risk, or you know, do they actually sometimes disagree with the score and will override it? You know, these tests around evaluations, any documents describing the training data. So how big is the training data? How, you know, how many women versus how many men? You know, how was it collected? Was it a random sample, or was it based off of, you know, past investigations? Training data, asterisks there, because I'm going to talk about that a little bit later. And then lastly, like kind of run-of-the-mill data protection impact assessments. These are kind of just documents to fall back on if the agency doesn't want to give you any of this stuff. So that FOIA looks great and everything, but like, I'm sure some of you in the room are like, yeah, but you're like, nobody's going to give you all of that. That was true to a degree. So we started FOIAing across Europe, and we got this very like patchwork of responses back. So sometimes we would get, sometimes nothing. Sometimes we'd get like these technical documents, but no code. Sometimes we would get code but no technical documents, so we didn't know how to understand it. And it's like worth mentioning that, you know, you don't need all of the things I just described in order to do this reporting. So even if you have like a patchwork of documents, you can still do really good algorithmic accountability stories. And in fact, some of the stories that we've done after Rotterdam, so like in Spain, for example, relied on a less complete look at the picture, and they were still really effective stories. But back to Rotterdam, when we originally sent our FOI to Rotterdam, we were really pleasantly surprised because they sent us back code immediately. So we were, of course, over the moon about this. Okay, we have code, and we started looking through it, and then when we started looking through this code, we noticed that there was like this one file that was missing. It was called the final model file, .rds. And that was the file that was actually capable of calculating risk scores. So essentially the file we really needed to do this experiment. And so I emailed them and I was like, hey, like I think you guys made a mistake. There's this file missing. They were like, no, that's not a mistake, and you're like never gonna get that. So what ensued was like this sort of 1-year battle with like multiple FOIAs, multiple appeal processes, and like these kind of intermittent like sideline negotiations, if you want to call them that, where we were like, okay, like maybe you can't give us the model, but can you, will you like give us synthetic training data or something like that, and we'll like, you know, build our own model, and you know, then they would say yes, and then they'd say no. And eventually where it ended up was we had like this preliminary hearing, and you could kind of tell that this was preliminary hearing with the city and you know, the sort of independent committee, which is how it works in the Netherlands. And you could tell this was sort of uncharted waters within like Dutch FOIA, because at one moment, one of those committee members who sort of has the right to review the document in question to decide whether the city is justified in refusing it, asked if they could send this final model file as a PDF. And obviously they couldn't. And basically like 2 days after that meeting, the city invited us to like this sort of negotiation, and you know, we talked about this this exception that is commonly used if you're like ever looking at risk assessments in FOIA. So in the UK, you have a version of it as well, which is like this control. In the UK, it's like called control and prevention of crime, I think. In other contexts, it's called the control exception. And it's an exception that allows you to not release a document if it will hinder an authority's ability to control for a crime or offense. But our argument was, in this case, that exception shouldn't apply because so many of the variables in the Rotterdam system are things that people are impossible or nearly impossible to change. So legally changing your age, which is the most important variable for the algorithm, who is going to do that? You know, somehow lying about the fact that you have children. I mean, that's something that's held in a public database. So like realistically changing, and you wouldn't have to change, you'd have to change multiple of these things to bring your risk score down. So it just isn't realistic. And if any of you are trying to get access to similar models, I'd recommend using similar argumentation. And furthermore, there's a lot of academic literature about this, what they call the gaming argument. You know, are people actually able to game these systems that you can reference? And so, yeah, we're sitting across from Rotterdam, and we have this negotiation. And, you know, one thing I will say, doing a lot of FOIA across Europe, like I wouldn't underestimate this human aspect of FOIA. So I'd been talking a lot with one of the FOIA officers and you know, sort of building a relationship, and she ended up being sort of an advocate for handing over the model in the room, which is really important for us. And eventually the city did decide to hand it over and told us to never send a FOIA again. And Dutch directness.
So was she quite sympathetic?
So the FOIA officer was very sympathetic, and I'd sort of been calling her and stuff because she had a PhD in philosophy, this FOIA officer. So I was like, okay, she might be sympathetic to what we're trying to do. And then there was the sort of director of the Rotterdam Welfare Authority. And she was like not very sympathetic, but we just like kept FOIAing and we're kind of like, okay, we're gonna take you to court. And she just kind of wanted it to be done, was the sense I got from her. So in all of this as well, the training data, so how did we end up with this training data? The city refused the training data to us on data privacy concerns, which is completely correct. They are completely justified to do that. In fact, if they did give us the training data, that would be a violation of GDPR. So we asked the city for essentially a set of histograms, so distributions of each of the variables in the training data. So essentially, like you can see here, this is the distribution of ages in the training data. So we had some idea what it looked like. And since there was 315 of these graphs in this HTML file, my colleague Justin, who's our lead data scientist on this project, was like, okay, I'm too lazy to go and like type all of this, like extract all of these column values out. So he went and he clicked like inspect element, and lo and behold, all the real training data was stored in the document. So they accidentally leaked us the entire training data set. So if you look and try to get access to training data, you can try to ask them to send you HTML histograms in Plotly. So with that, we had everything. I'm gonna switch tact a little bit and talk about the human dimension of all of this. So trying to find people who are willing to talk about being put under investigation and establishing this red thread, so knowing that they were selected by an algorithm and not some other means, like an anonymous tip, was just as challenging as getting access to the model. And the reasons for this are there's huge distrust and fear within those communities, especially those that have been victims of, you know, what I think can only be described as a really punitive system. So that involved months of community level reporting from my colleague Eveline and this local paper I'm going to talk about in a second. One of the strategies we made use of, and which I think is really underused in this space, is subject access requests. For those who aren't aware, under data protection laws, also in the UK, you have the right to request what data an authority holds on you. And so what we did in our case was we had people send in subject access requests to get their risk score and all the values for these different variables. And what people got back was really shocking. So one of our case studies whose investigation put him in a terrible mental space. You can see here this row 178, the algorithm, one of the variables is whether you struggle psychologically. And you can see here that that had been logged. And he found that quite disturbing. He's also a second-generation Turkish migrant. And this row 179 logs the fact that he speaks Turkish at home. And from a storytelling perspective, having this is quite powerful as well, because then you have someone's real story and you can sort of interlay that with how the complicated lives of people in the system are sort of flattened into this, a spreadsheet. We also worked, and this is, it's not every day that Wired is working with a local Rotterdam Metro paper, but in this case it worked extremely well to have this really local perspective from First Baton, which is a Metro paper there. And they had, trust in the community there and could go, and they hit the streets for 3 months, going to these different community centers of especially mothers community centers, because we'd established that being a single mother was a high-risk profile. It still took a long time. They also had this really strong local knowledge, context knowledge. So for example, this graph on the, this chart on the right is all the different neighborhoods in Rotterdam, and the shade of red is how risky, how much they add to your risk score in the algorithm. And they had a strong understanding of what that meant, really, and knew people in each of these places. And then most importantly of all is like they had the ability to actually reach people most affected with the publication. So your average Rotterdammer is not a Wired subscriber. Okay, so back to the experiment. What did we actually do once we got all this material? We designed 2 different types of experiments. So non-controlled, so that just looked at, okay, do women receive higher scores than men? But then we wanted to do a controlled version of this to understand, do women receive higher scores than men because of a change in gender? And to do this controlled version of the experiment, we took the training data set, we made 2 copies of it, one where everyone was a man, one where everyone was a woman, and then we looked at different metrics. So we got the average of the all-man data set, the average of all the all-woman data set, and looked at the delta. And then what we also did was we looked at the percentage of people who are suddenly now in the high-risk threshold. So the sort of, what that metric means is like how many people who, if they had been a man, would have never been selected for investigation, now that they are a woman, would have been selected for investigation. And then for variables that are continuous, so like children, we looked at the ranges and did so 1 copy of the data set where everyone has 0 children, 1 copy where everyone has 1, 2, 3, on and on. And you can see here, like this is the impact of language on different risk scores, so you can see clear, so how many people are in the highest risk percentage decile, and you can see there's a very clear inverse relationship between speaking another language and speaking Dutch. But one of the challenges was looking at combinations. So with 315 variables, running every combination, and you sort of run every possible permutation, that's like, I don't know, my lead data scientist said that's like as many particles as there are in the universe. I don't know if I could like believe him, but it's a lot. And you'd need like a bunch of supercomputers to run that, and obviously we didn't have that. And the other challenge was that since this is a nonlinear machine learning model, so you have all these different decision trees, what that means in effect is that different variables affect the same, affect the same people differently. Sorry, no, affect different people differently. So for example, changing someone's gender from man to woman could mean more if they're living in one neighborhood versus another. Or speaking Dutch could lower your score with a certain combination of variables, but actually raise your score with another combination of variables. So how do you test for that? And what we did was we looked at these single variable results, and we created a bunch of these sort of what we call human readable archetypes. And ran a bunch of tests on these different archetypes that were combinations of around 5 or 6 different variables, and then did the same sort of controlled versus non-controlled version of the test. So you can see here, like, this is what they actually looked like in practice. So here we have like woman, parent, non-Dutch, lives in migrant neighborhood, struggling financially, and high time, like a lot of time needed to reintegrate into the labor market, and 26.45% of the people in that data set where everyone looks like this is in the high risk category. And then we kind of did this anti-archetype, if you will, and only 5% were high risk in that data set. And the other reason that we kind of took this approach was, how do we, like, you can throw someone a bunch of these like single variable results. So, on average, being a woman increases your score this much. But we wanted to try to create like humanized profiles to really make the point home that it's not just single changes in one variable that matter, but effectively people fall across the intersection of these different things, right? Woman, parent, migration background. And that's, the results are pretty dramatic. I mean, you add a few more variables to this top one and you can get 50% of the data set being high risk. Then we had to bulletproof everything. And it was sort of uncharted waters, at least in journalism. So there was a lot of anxiety here that we do it right. We took a lot of inspiration from the Markup, which is a US data journalism newsroom, who's sort of, I would argue, pioneered this idea of the methodology. So having a methodology along with your story that explains everything you did and how you did it, that's actually published with the story. And what we did was we had our methodology reviewed by a panel of academics, both before and after running the experiment. And that was an incredibly useful process. And I will say as well, I was really, it was amazing to see how willing different academics were to give their time to do that. And then we published the methodology online, along with the story. And I think most importantly is we also, all the results and the code, including this algorithm itself, we published on GitHub so people could reproduce what we did. And I think importantly as well is like, because there's so many different variables, like 315 that just cover so many different things, we just didn't have the time to test everything we wanted to test. So there's, for example, I think there's some really interesting work to be done exploring the interaction between disability and the algorithm, because there are certain variables that have to do with that. So for example, having also with illness as well. So a few things that I wish I had known before, and maybe for those of you who want to take this work on yourself. I really wish I'd had a clear understanding of what to ask for and how to get it. So you've seen what the FOIA looks like now. That's not what it looked like at the beginning. It was, much more piecemeal, and I just lost a ton of time, missing one thing I should have asked for, or understanding that, this type of system, this type of document wouldn't be relevant. I talked a lot about the methodology. For me, for this type of project, the methodology should be, as my colleague Dhruv Marotta from Wired said, like the Bible that sort of guides the investigation. So we started writing our methodology after we were running already had started running tests on the algorithm. And it should have been a living, sort of growing organic document that you keep referring back to. And I think the end result is our methodology is a bit, not a bit, very dense, like 6,000 words, like sluggish. I think it could have been 2/3 of that and been way punchier, but we were just so stressed trying to make the deadline of the final story that we just didn't have time to like really, I think, do a better job. This is important, this point, especially if anybody here wants to take this on and is dealing with authorities that are not willing to play ball with any of this stuff. Like this code access that we got was really great, obviously. It allowed us to tell, I think, a really interesting story. But statistics on the outputs, to me, are just as powerful. So what that looks like in practice would be saying, you know, how many women does, asking how many women does the algorithm flag versus how many men. What are the error rates? So, you know, does the algorithm more often make errors on women versus men? And the important thing here is that these types of statistics can be obtained in other ways besides FOIA. So something that we've been trying in some of the other countries we're working in that we're going to be publishing about in the fall is having MPs ask for these statistics, because then, at least in continental Europe, I'm not sure about in the UK, but in continental Europe, if a MP asks these questions, then the authority is compelled to answer. And that's been successful. And in the end, like, these outputs are what you really need to tackle the fairness question. Like, all the stuff before it, you can talk about, okay, what does discrimination look like technically in the black box? How did it learn these associations? But in the end, like, the fairness question is, you know, is there a disproportionate impact on different groups? You know, does the algorithm have a higher error rate among women than men? That's what you need to tell a fairness story, to say that the system isn't functioning fairly. And then the last thing is don't reinvent the wheel. So I think one of the misconceptions of this type of reporting is that you need to have like in-house like some machine learning AI specialist, and that's just not true. Like, we have brilliant data team at Lighthouse Reports, my colleagues, but and one of them especially, like, took 2 classes in machine learning. He's a brilliant guy in college, but that's it. He doesn't have a degree in like computer science. He has a degree in like sociology or something. And the reason why you don't need to have that is because there's a bunch of academics who are thinking about these questions all the time and who you can lean on for this type of stuff, and who themselves are really looking for new case studies. They're looking for new data. I mean, if there's been like 100 papers written about machine bias, because that's been like the only example up until now of like a risk assessment system where there's data that people can run tests on. So, they've been thinking about a lot of these questions as well, also around like how do you access these things and gaming arguments. So yeah, those are the sort of the 4 things I wish I'd known. Yeah, so this is a machine learning algorithm, so it's learning from a training data set. So it learns associations from that training data set. But the problem with Rotterdam's data is that it's not a random sample of people. So it's based off of past investigations. So the same biases will be implicit there. And further, and we talk about this in the methodology, without getting like too technical, there was different sampling strategies for getting people into the training data set. Those different sampling strategies had different rates of fraud in them, and different groups came in to the data set via different sampling strategies. So to be more concrete, so one of the ways that Rotterdam used to do its investigations would be to say, okay, this year we're going to check every man living in X postcode. And these types of investigations have a very low rate of catching fraud. And another way that they would put people into the training data was to say, another way they'd investigate someone was to say, like, okay, anonymous tips. So your neighbor is like snitches and like, you're on welfare, but I saw this person driving around in a new car. And that has a higher rate of catching fraud. But we know that more women are anonymously reported than men, and more men come in through these theme checks where you check a postcode, what that means is that the algorithm learns a flawed association because more women are reported than men, and that has a higher rate of catching fraud, so it makes this association, right? So the correct way to train an algorithm like this would have been to do a random sample of everyone receiving welfare. So that's a long rambling answer, but no, it wasn't just some person like deciding that, oh, having children is indicative of fraud. This is since it's machine learning, it's the algorithm itself that's picking up these relationships. I've seen ones that I think use less problematic factors. But I don't know, I don't think I've seen one that works really well. That's like kind of an interesting thing in itself. And I think the reason for that is that fraud, at least in continental Europe, welfare fraud is incredibly rare. You know, the consultancies will like put out these inflated statistics, but when you actually have like independent audit institutes like the French Court of Audit look at it, I mean, it's below 0.2% of all benefits paid. And so training a model to try to find something that's so rare is difficult and have it work well. But, you know, this is my own experience. There are a lot of things that you can do to make, like, for example, the Rotterdam system better that they didn't do. So who knows what it would have looked like if they'd done those things.
Have you had any engagement with the developers since the reporting?
Not Accenture, like, just send a sentence back saying, like, we gave this to the city in 2018. Essentially, like, it's their problem. Rotterdam themselves had actually a really graceful response, I felt. So they said something along the lines of, you know, we found your experiment really insightful and a warning to other cities across the continent who are trying to deploy similar systems, and we think it's important for them to be open and transparent too, which is kind of rare in our line of work. That's to do with, I mean, these decision trees are essentially relationships that the algorithm has seen within the training data. So that one looks kind of clear. In actuality, a lot of them look kind of weird and random looking. So yeah, the reason that you'll have that split is because the machine learning model thinks that there is a relationship between gender, like being a woman and having children, and sees a relationship with the outcome variable, which is risk, right, between being a man and language. But there's 500 of these decision trees, so you may see, like, you'll still see women sometimes asked in these decision trees about their language proficiency, but you'll just see it more often asked to men. I think actually that's something that's like really under talked about in this space, is like how, I mean, like you would think administratively that like the same people should be different people should be judged in the same way. And with these decision trees, you have people being judged by different characteristics, and I think there's a larger question to be had of whether that's even compatible with the idea of how the administrative state should function. Yeah, so they stopped using the system and said they want to build a new one. They call it the glass box model. But they sent like a sort of council letter that makes me think it may not happen, which they said, like, we're trying to work on this, but it's really hard to make a system that's fair, transparent, and legal. And yeah, so it's gonna, yeah. So it felt to me like they were saying that they're going to, and since then they've started randomly selecting people for these investigations, which, again, like whether you're randomly selected or picked by an algorithm, the investigation is just as punitive, so. I think that there's maybe a few reasons, but first and foremost, we've had in the Netherlands already like a big scandal over AI and welfare on the national level. So I think there's been more public pressure to be transparent about these types of systems, to prove that you aren't doing the same thing. But I will say as well, I mean, Rotterdam was really where we invested the time to get the model. So there was no way we could have invested like Rotterdam level energy into doing this, trying to get this in like all the different places we were working. So we felt that there was some sort of opening here when they first sent us that code, which was, you know, pretty transparent even to start. So we felt like we had a foothold, and this would be the place to like invest our time and energy into like really hammering them to get this thing. I'm not sure what would have happened if we had invested that amount of time in some of the other places. There's a few that I think that we probably would have gotten similar access in the end, and there's some where even after all that effort, I don't think we would have. It's a little above my pay grade. I think there's a lot of really smart people who have been thinking about that. If I'm being completely honest, I'm a little undecided. I mean, I think like what I would like to be presented with is like, what is the best version of this? What does that look like? And then, you know, then that's a baseline where you can answer that question, I think. But so far, like all I've seen is really flawed, discriminatory systems that look like this one. But I think in a sense, like I'd argue in the case of Rotterdam and some of the other places we're talking about, the question almost misses the point. So like if you build a really, like the perfect version of the Rotterdam system, but it's still embedded within this really punitive welfare state where the aim, like you said, is to kick people off of welfare, then you've like made a really nice, shiny piece of duct tape that you put over like a much larger punitive systemic problem in the country. So it's challenging, I guess is the answer. It hasn't become standard yet to do those yet in continental Europe. Under the EU new AI Act, they will be. I think in the UK, it is more standard to do that type of assessment. So no, we got a lot of data protection impact assessments back. And feel free to reach out one of the things that we're trying to do is encourage other newsrooms to take on this type of reporting more. So if you want to do this and you are struggling to try to figure out where to start, we're really open to have a chat and give you some tips and stuff. Cool, I think I'll end now so we can get some coffee. Thank you.